Welcome dear students, we have already discussed in detail the optical isomerism, and this lecture is about a small trick to calculate the number of possible optical isomers of an organic compound. My dear students, when an organic compound is written in front of you, first of all you will look at the structure of that molecule and you will find the number of chiral centers that molecule has. When a molecule has no symmetry. The first case is that there is an optically active organic compound and it has no symmetry, means it cannot be divided into two equal parts by any plane. Then the optically active isomers that are shown with small a, that will be equal to 2 raised to power n. And what is n? That is the number of chiral centers that molecule has, mean the number of chiral carbons in that molecule. And in this case, when the molecule has no symmetry and it is indivisible, it cannot be divided into two equal halves by any plane, then its meso isomers that will be equal to 0. It will not show mesomerism. There will be no meso compounds for that optically active organic compound. And the total isomers, they are always equal to optically active isomers plus mesomers. So basically the total number of optical isomer will be shown by the formula A plus N. Now let us look at this example. My dear students, you can see that this is an organic compound which has only one chiral center. There is only one stereogenic carbon in this organic compound. So the value of N for this organic compound, that should be equal to 1. Now, my dear students, how many optically active isomers A it will have? That will be equal to 2 raised to power 1 and it will be equal to 2. And as we have already discussed that mesomers in this case, they will be equal to 0. So total optical isomers, that will be equal to A plus M and it will be equal to 2 plus 0 and the answer will be 2. So there are only two optical isomers possible for this organic compound, and you can see that there is no symmetry in this organic compound. It cannot be divided into two equal halves by any plane. Similarly, this one is the glucose, and how many optical centers in the glucose are there? 1, 2, 3, 4. So for this glucose, N should be equal to 4. And what will be the value of A for this glucose? A is equal to 2 raised to power n, so that will be 2 raised to power 4, and you know 2 raised to power 4, that is equal to 16, and it will be having no mesomers. So total number of optical isomers for glucose, they will be A plus M, and that will be 16 plus 0 and it will be 16. So it means that the 16 optical isomers are possible for the glucose. My dear students, next is the case in which a molecule has symmetry. Means the molecule has chiral centers, but the symmetry is also there in the molecule and it can be divided into two equal halves by any plane. In that case, then you will look at the stereogenic centers or stereogenic carbons, whether they are even or odd. If the n is even number, mean there are even number of the chiral centers in that molecule, then optically active isomer A formula will be 2 raised to power n minus 1 and it will show mesoforms. So the mesoform M, that will be equal to 2 raised to power 2 over n minus 1. Now this one is an example in front of you. In this organic compound, you can see that there are two chiral centers or stereogenic centers. So that is an even number, and this red dotted line shows the plane where this molecule can be cut into two equal halves. In that case, now the optically active isomer formula is 2 raised to power n minus 1. That will be equal to 2 raised to power n is equal to 2, 2 minus 1, and that will be 2 raised to power 1 and it will be equal to 2. Now, my dear students, the mesoforms, that is equal to 2 raised to power 2 divided by n. In this case, n is 2 minus 1. So that will be 2 raised to power 1 minus 1 and it will be 2 raised to power 0. And my dear students, you know that the power of any if that is 0, it becomes 1. So total optical isomers, that will be equal to A plus M. A is 2, M is 1, and that will be equal to 3. Now, out of these three, there will be two optically active isomers, one dextrorotatory, other will be the levorotatory, and there will be one mesoform of that organic compound. And if, my dear students, the n is odd number, mean there is a molecule which has odd number of the stereogenic centers, then optically active isomer formula will be 2 raised to power n minus 1 plus 2 raised to power n minus 1 divided by 2. Mesoform 2 raised to power n minus 1 over 2. And the total optical isomers, that will be A plus M. In this case now, there are three stereogenic centers. So for this compound, n will be equal to 3. Now putting values in these formulas, A should be equal to 2 raised to power 3 minus 1 plus 2 raised to power 3 minus 1 divided by 2. It will become 2 raised to power 3 minus 1, 2 raised to power 2 plus 3 minus 1 is 2, 2 divided by 2, that will be 1. So 2 raised to power 1. Now the square of 2, that will be equal to 4, and 2 raised to power 1, that will be equal to 2. So there will be 6 optical isomers, optically active isomers of this organic compound. And my dear students, now let us calculate M2 raised to power 3 minus 1 divided by 2 means 2 raised to power 2 over 2, that will be 2 raised to power 1, and it will be equal to 2. So the value of M, that is 2, and the value of A, that is 6. So total optical isomers, that will be equal to 2 plus 6, and it will be equal to 8. So in this organic compound, there will be 8 isomers, out of which you can see that the 6 will be the optically active isomers, and there will be 2 mesoforms of this organic compound, and the total optical isomers will be 8. So in this way, just looking at the number of the chiral centers in an organic compound, you can find its possible optically active isomers, mesoforms, and total optical isomers. And this lecture will be very useful when you will be discussing the MCQs, or you will be practicing the MCQs, that the structure of the organic compound is given and you are required to calculate its total number of the optical isomers. Then you can take help from this lecture. I hope so that this lecture will be very understandable for you people. In case you find any problem, you can ask in the comment section. I will answer. Till then, take care.